Yeah, good evening. So welcome to today's session. So in today's session, the topic what we are going to discuss is not a part of mid-semester syllabus, but it is one of the important concept in analytics. So that is regression. So we'll spend the time on the regression and so why to go for the discussion, how to go for the discussion regression, and what are the types that we had. So various points. This is one of the important concept in predictive analytics. I think some of you are familiar with respect to this. May not be in detail. You may be aware of this term. That is, the regression is the one which we use regularly. So what is the regression analysis? So what is that it talks about, and so what are the applications related to it? So any guess, any idea like that? What is this regression analysis all about? So what is the importance of this? Basically, what is that we are going to do in this regression analysis? Any clue? So now this is something like if you remember the earlier discussion what we had in the last session, that is where we try to find the relation. We try to see whether there is a relation between two variables or not, if you remember. Right? Now it is something like, suppose you want to find out, we want to find out whether the expenditure depends on income or not. Right? So then what to do? So we want to find whether the expenditure depends on income or not. This is what we want to find. If so, how they are related? How they are related means whether income increases, expenditure also increases, income decreases, expenditure increases, like whether they are proportional or inversely proportional. So we want to find whether these two variables are having any relation or not. So how to do this analysis, or how to answer this query? So then we take the data from the past where we have these two variables. One is the income and other one is the expenditure. So then we try to use an appropriate tool to establish and come out with an answer, right? So that tool or the topic or whatever it is the one what we discussed, that is correlation, right? Correlation is the topic or the concept we use to find whether there exists a relation between two variables or not. So if so, which type of relation? Which type of relation in the sense it is, if you remember the last class discussion, that is whether they are positively correlated or negatively correlated. And that is what we call as correlation, for which we use one quantified term, that is we had some quantification of that, that is called Pearson's coefficient of correlation. So based on that, we'll say these two variables are having relation or not. If so, which type of relation, etc., etc. So now, once we know that there is a relation, then what is the next step that we look for? So now, suppose you think of some applications like agriculture, right? So in agriculture, it is something like if the input, that is, if you increase fertilizers, then the yield also increases. If you increase fertilizers, There is nothing like that. The yield depends on the amount of fertilizer that we are giving. That is input. So now we want to find this, right? We want to establish whether this is a fact or not. So then what to do? Just take the data from the past. That is the amount of the fertilizers used and what is the yield. Okay. Then we try to find by using the method, that is what we discussed, the coefficient of correlation, particularly the Pearson coefficient of correlation we use. Then based on that we will come out with a conclusion saying that these two are related or there is no relation between these two, and they are perfectly positively correlated, negatively correlated, etc., etc. So this gives us an understanding of what we are looking for. That is one application. Now, once suppose we are able to establish, right? If we are able to establish that there is a relation between the amount of fertilizers used and the yield that we get. So now, as a suppose inventory or as a policy maker, you want to find out. So what is the inventory that I need to maintain for the next crop or next season? Right? So we want to, now we know there is a relation between these two. That is, suppose if the input increases, then the output also increases. Then if you see the policy, then we'll have the targets for the crops. Right? So this year expected the target for the so and so crop is this, like the government of India decides. Now based on this, I want to find out how much fertilizers I require. So for which what we do is we'll take the data and we'll try to find the relation. We'll try to find whether relation exists or not. Next, what we do is we want to find out the relation between the two. So that is what that means we'll predict it, right? We'll predict it for the next season, for the next season, for the next season, right? That means not only having an understanding of whether the two variables are related or not, and also we want to extend it further to say that what is the relation between these two. A relation between the two means we want to have one kind of equation. So that is nothing but the equation. I hope that it is clear. What is the difference between correlation and regression? Okay. Right. So similarly, many examples you can have industrial, like it is the performance of a machine over a period, right? Healthcare. Right? So various ways we want to, based on the past data, we want to predict it for the next. Right? So similarly, how much inventory we need to maintain, etc. So many applications are there where based on the data we want to predict for given values in the near future. So that discussion comes under regression analysis. So I think it is very clear. So there we use two terms. One is correlation, other one is regression. Correlation is a term which helps us to understand whether the two variables are having any relation or not. It gives an idea, like feel of like whether these two are related or not. If not, then no need of taking it further, right, for prediction. So once we had an idea with respect to the relation that based on the coefficient of correlation or correlation concept, next step is we try to go further with the regression. Regression is something where we try to establish a relation between the two variables. Not only two, later we can extend it further. Right? So first one is find verification of or validation of whether these two are related or not. Next follows is establishing that relation, and third one comes actually that is actually what we require is the estimations or the predictions based on the data, based on the model that we use. We'll try to predict it for the next values. So this is the complete process. So any inputs or any thoughts, any of your own observation that you had with respect to LHP? Any of observation that you had with respect to applications of this? So why is it fine now, or whether voice is clear? Yeah, stock market prediction is one of the good examples that we can say. So here prediction, various types actually, various types of predictions like where later what we are going to see is the time series analysis is one of the. Time series is the one which is very important when we take stock market analysis kind of applications. So is it fine now? How is the voice now? Yeah. So now again I repeat because this understanding the process is very important. So now we had like we'll see it in 3 steps. So suppose we want to find out, suppose if you take an application related to agriculture, right, or inventory, you can take agriculture. Now, so 2 parameters we had. So what are those 2 parameters? One is so here 2 parameters. One is the amount of fertilizers and the crop yield. Suppose farmers are having, or we are having an assumption that if you use more fertilizers, then the crop yield increases. Right? So then how to validate it? How to validate this? Right? So how to validate this means, that means we want to find out whether these 2 are having any relation or not. Very simple example. Suppose if I say, if you attend classes regularly, your performance will be very good. Suppose that is an assumption that I had as a teacher. Right? If you are regular to the class, then your performance will be very good. That is my assumption, that these 2 are proportional. Right? Now how to, that is my assumption, right? Then how to find out? Now I'll take the 1 semester, 2 semesters data, that is number of classes attended, then so the scores, it may be grades or marks. Right? Now I had two variables. One variable related to number of classes attended, and other one is the marks scored or grades that we had. So now I want a tool to validate my assumption with the data what I had. So that tool is called as the correlation. Correlation is the one which quantifies or which helps us to understand this. So then the correlation, some formula what we had yesterday. So by using that, now that is what we call a Carl-Pearson coefficient of correlation, which is R. So based on R, we can validate our assumption. Suppose if R equal to 0, that says that your assumption is wrong. There is no relation between the regularity in attending the class and the performance in the examination. Right? Like this, suppose if R equal to 1, if R equal to positive, then it says positive, it says that means if you attend classes, then your performance increases. Suppose if that value is negative, if you attend more number of classes, your performance decreases. Like this, we can understand the relation between 2 variables. Right? That is, like here in this example, the crop yield and the amount of fertilizers used both are having a relation or not. That is clear. Next thing is, now as the authority concerned, you want to find how much inventory that I need to maintain for the next season, right? To avoid any kind of shortage of fertilizers. So that means now we know the relation. Next is how much amount of fertilizers I have to put as an inventory, or I have to be ready with for the next season, right? So that means, so next step is, once I know that there is a relation, I want to establish that relation. That relation means it is something like y equal to 2x, y equal to x square, like this. Then when x equal to 100, I'll get 200. That is my estimation, or that is my prediction. Right? So that concept is called as a regression.
right? Correlation is something which talks about the existence of a relation. A regression is something which gives the relation. Next, third step is once we have the relation, then we can use it to estimate. So many examples we had, like stock market prediction. One of our friends responded. No, it is regression is something is not related to continuous random variable. Okay. Now suppose this is example, right? Suppose it is the same like what we discussed. X is related to the amount of fertilizer used in quintals or metric tons, whatever it is, right? And Y is the output, the crop yield per hectare, per acre, whatever, the uniform unit. Right? This is what we had. Right? This is the data what we collected. Then based on this, so we want to do many things. One is whether the fertilizer input is having any dependency or any relation on the output, that is crop yield. Right? So for which what we have to do is we have to use the concept called as correlation. Right? Correlation is the concept. Right? Next, what I want to find is like this we have, right? This is maybe 6 tons of fertilizers I used, then 36 is what I got. Now I want to find out when X equal to 8, right? Like this. Now this is the present data what we had. Now based on this, I want to find if I increase X, if X is 8, then what is my requirement? That means based on this data, I want to predict it for the future when X equal to 8. Right? So for this, what we require, right? So we need some relation between the two variables. So what is that now? Here in this case, if you see, it is very easy for us to understand or identify a relation between the, not only two, actually we will extend. So if you see here, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36. Not only if we plot also, we can see an exact pattern here. That means if you see Y equal to X square is the one which fits into their data, right? Right. So we are able to establish a relation between the two variables Y equal to X square. Right? So this is what we call as regression. Right. I hope that it is clear. The relation or the difference between correlation and regression. Right? Correlation is something which gives a feel of the relation, and regression exactly gives what is that relation that the two variables are having. Right? So once we have this Y equal to X square, then we can predict it. That is when X equal to 8, Y equal to 64, and X equal to 10, Y equal to 100, like this. Right? So this is what we call as this entire way of doing this thing is called as regression or regression analysis. Right? So where here one is called as dependent variable, other one is called as independent variable here. So Y is the one which depends on X. Y is the one which depends on X. Therefore, X is called as independent variable, and Y is called as dependent variable. Right? Okay. Is there any difficulty in doing this? Now I think it seems very easy, right? Just try to establish a relation so that we can do the estimation, predictions, etc., etc. Right? Are you able to see any difficulty in doing this? Is there any problem in using this concept? Is there any difficulty if you want to use this concept? I think it is very easy, right? So no difficulty, right? If not difficult, we'll try with one more problem. Now we had this income and expenditure in lakhs. This is the past data what we had. When X is the income is 25 lakhs, then expenditure is 6 lakhs. 38, 25, 15, 7, 18, 4, 22, 5. Then if x equal to 32, then how much expenditure that I can expect? So any answer for this? It is just like this, right? So what will be the answer for this? Any guess, any try where what will be the y value when x is 32? Approximately 8.5, approximately 9. Okay. So what is the what we call as, what is the process that you apply to arrive at some value 8, 9, etc. Right? 8.5 or 9. So what is the difference between this and this? What is the difference between this and this expression? So that is the difficulty we see in doing the regression analysis. So here it is not that easy to find a relation between the two variables, because they are not following a fixed pattern like what we have seen, right? So it is not here in this case all the points are following a fixed pattern, that is they are all are following a path, that is y equal to x square, a parabola kind of nonlinear expression, right? But when we come to this, so now if you see in most of the applications, or if you take the real data which is of this kind only, right? So in general, so most of the data what we had is unsupervised, what we call as asynchronous, right? Asynchronous data what we had. Right? So this is the reality actually. So we are going to deal with data which is of this kind, which is asynchronous. So in such cases, how to establish a relation, right? In such cases, how to establish the relation? This is the major problem with respect to regression, right? Okay. Now, how to do this? Now, if I take this, now suppose I took the data and I used the scatter plot. Scatter plot is the technique which I used. Then I had this actually same, both are the, assume both are the same, right? Both are the same, all the points I plotted and I am able to get this. Now can you try what, just forget about the lines which I draw or the curve which I draw. Now these are the points, dots are the points of the data what we had, right? Now how to find a relation based on the scattered plot what we had, right? So is it something like this? I will draw a curve like this, I will draw a curve like this, I will draw a curve like this, like this, like this, like this. Can you suggest me to do like this and come out with a equation for this, right? Right? Is it the right way to do that? That is, draw a curve, freehand curve which passes through all the points. I think right, no? Right? Then what is the equation of this? Right? What is the equation of this plot? Right? So that is where the regression comes into picture. Right? Take the nearest must be a straight line. So here actually, if you see this, suppose both are the same. Here I use two kinds of expressions. One is, if you see this, I draw a straight line. I draw a parabola kind of curve. Right? So from your observations, which one is most apt for this? You feel whether this is the apt one or this is the apt one. Assume that both are the same data points. Which one you are feeling like a good thing to use? Second one, right? Second one is most appropriate, right? Not the first one. Right? Just by seeing, we can say this is the most appropriate curve which gives a pattern that the most of the points follows, right? Comparing with this. And what are the other observations? Why you are saying this is appropriate and this is most appropriate comparing with this? So what is the reason? Non-linear, very good. It covers most of the points, right? It covers most of the points. Means, as I mentioned, it is very difficult to have a curve which passes through all the points, right? Like what I have drawn. So a curve which passes through all the points is a very difficult task. Then what is the best thing what we can do is we can have an expression, curve, a line, where most of the points are nearer to it, right? Most of the points are nearer to it. So how to find that most of the, right? So PS, right, I'll just 1 minute. Pearson coefficient, it won't say about the type of relation, linear, non-linear. It says yes, relation is there. Right? Again, I repeat, Pearson, the correlation coefficient won't say anything about linear, non-linear, parabola, straight line, etc. Just it says yes, both are having relation. Both are having relation. And it says yeah, there is a relation which is positive way, which is the relation which is in a negative way, and it says it is no way there is a relation between the two variables. Right? It never gives any clue with respect to linear or non-linear. Right? It never gives. It says yes, there is a relation. It is our job to find out that relation with the help of this regression concept. I hope that it is clear, right? Right? So it is our job. Correlation never helps us to say it is linear, non-linear. It is our job to find out whether it is a linear or non-linear with the help of the concept called as regression analysis. Right. Now, how to do it? Now, one more thing here is actually this is also fine. This is also fine. Depends on. Generally, we say it is most, but in generalized fashion, it depends on the application that you are working, right? So sometimes it is not, there is nothing like a thumb rule says that this is the best among all. So it depends on the relation. If the application or the data what you had, what you are working with is okay if you go with a linear relation, then it is also good. But if your application or if your data is more specific, more important, then you have to go further and further with a non-linear relation. That is also another important. That's why there is no thumb rule says that this is the best. Right? Maybe I can correlate this with those. If you had any idea, very good. Otherwise, also no issue. If you are aware of the k nearest neighbor, right? When you go for clustering, right? When you go for clustering, when you go for k nearest neighbor, right? Suppose you had 10 data points. Suppose you have 10 data points. How many clusters you can go for? Those who are familiar with respect to this topic, then only. Don't otherwise leave it. We leave it. If you are familiar with respect to clusters, where k nearest neighbor, k means what is that algorithm we use, right? KNN algorithm. Suppose I had 10 data points, right? 10 data points we had. How many clusters we can make? We can have how many clusters where the clusterization is most optimal, most perfect? Any clue if you had any idea? KNN algorithm if you use 10, right? Because every point is a cluster, but whether it makes any sense if I go for every point as a cluster? Because 1 to 10 is always good. I can have 1 cluster, I can have max 10 clusters. The best one is making every point as a cluster, right? But whether it makes any sense if I take every point as a cluster, no, right? Then we have to see how it varies. But in sense, if I want to have the perfect clustering, I have to take each point as a cluster, right? but it doesn't make any sense. It creates many problems with respect to it. Right? So why I am saying is this here also I can have a line the curve which passes through all the points, right? Actually, this is the perfect fit for the data, but it is not wise thing to do it, and also very difficult to do it. That is one thing. And second thing is whether linear or non-linear way of doing the things, not only with respect to the concept what we are discussing, it depends on the application also. Suppose if I am working with some data related to the population and their voting pattern, or population and their expenditure, right? So there I want to try for a field or relation between these two, then this is also good for me, right? Instead of going for this. Suppose if we are working on a data which is related to some medical applications where we can't take a chance of inviting errors, right? Then we have to go for most optimal, even though it is costlier, time consuming, we have to go for more and more non-linear way of doing the things where error becomes minimal. Okay. So there is no thumb rule, it depends on application also. Now how to do this? Now very clear, right? Regression is something where we try to establish a relation. That means we'll try to draw either a straight line or any kind of curve. It may be a parabola, circle, ellipse, or whatever it is, right? We'll try to. So now based on these two examples or two diagrams, what we conclude is, so which one is optimal? Where most of the points are nearer to it, right? That is considered as the optimal one which fits into the data. Now if you see here, how many lines I can have? I can have a line like this, I can have a line like this, right? Like this, right? I can have a line like this, I can have a line like this, right? Many lines I can draw. So which one is correct? Which one is important for us? Which one is optimal for us? The optimal line is the one where most of the points are nearer to it. Most of the, there may be sometimes you may have the outliers. Right? Most of the points are nearer to the line. That is considered as the best fit for the data what we are working with, right? So that is the most of the points, right? But how to find this? How to decide what are the points which are nearer to it? Right? So that is very simple, right? Suppose I think here it should not be like this. It should be some. Shall I modify this? Because it is a y equal to mx actually, but it is not y equal to mx. We are working with this actually. Right. Now, so to do this, what we do is we use a concept called as method of least squares. Right? Method of least square errors, or people call it MLES, method of least square errors. Right? MLSE, method of least square errors, is the topic or the concept we use to find out a best possible relation that we can have between the two variables. So what is this method of least square concept says? It is called MLSE, method of least square errors, what we call as. Now suppose here if you see the dots, these are the data points. This is one point, this is another point, this is another point, like this, right? Like this. Right? Now we want to find out, first we are discussing in terms of a linear relation. Right? Suppose I try to fit one curve, one line y equal to mx plus c, that is straight line, which we are familiar with, y equal to beta naught plus beta 1x, right? So this one. So don't consider this what I have shown because it is y equal to mx actually. Now if you see here, this is the original point. When I draw the line, I am considering this point, right? This is actually original point. Instead of this, I am considering this. That means this is an error, right? Right? So similarly, this is the original point, second point, and this is what I am considering. So this is E2, similarly E3, similarly E4, similarly E5, and so on. So what are these E1, E2, E3, E4, E5? These are the errors, right? These are the errors. Now, just now what we discussed is we want to have a line or curve where most of the points are nearer to it, right? Most of the points are nearer to the line or the curve. Most of the points are nearer to the line or curve means what? This E1 should be minimal, right? It should be closer to the curve. It should be closer to the line, right? So that is nothing but, so we want to find out the values of beta naught and beta 1 where this E1, E2, E3, E4 and so on, this error becomes minimal. Right? But here, because this error can be a positive or it can be negative, right? It can be positive or it can be negative. So suppose if you take the errors as it is, sometimes what happens if you add all those errors, suppose here error is 2 plus 2, here it is minus 2, here plus 1, suppose minus 1, here plus 2, here minus 2, plus 3, minus 3. What we are saying is that total error has to be minimal, right? Suppose if I add this, what happens? Error becomes 0, right? Error becomes 0 means what? It should be a line or curve which passes through all the points, but here it is not happening, right? So that is the reason, to avoid that confusion, what we do is we'll take the squares actually. So we'll take the squares. That means we'll take error E1 and square, E1 square, next E2 square, E3 square, E4 square, E5 square and so on, and we'll sum these squares. Okay? And we'll try to see that this sum of squares becomes minimal. That is what we call as method of least square errors. Okay, is it clear? So why we are taking squares? Okay. So why actually error minimization we can say, right? Simple thing, right? So what just now what we discussed is it should be all the points should be nearer to the line or curve. All the points should be nearer to the line or curve means that E1, E2, E3 should be as much lesser as possible. But here as much lesser as possible, actually this E1, E2, E3 are nothing but errors. Okay. So now if I want to find out the total error and I want to have a line on the curve where this total error becomes very, very, very minimal. Because if you see here, you will have the options like this. This is one straight line, this is another straight line, this is another straight line, another straight line like this. So for each line we'll find sum of errors. Sum of errors means from what is the error with respect to this point, this point, this point like this. For every straight line we'll find the errors, and wherever these errors becomes minimal, that means all the points are nearer to it. That is the concept. Right? Right? But here if I take errors as it is, the error can be positive or error can be negative, right? Suppose here plus, that is, I repeat the same concept to have clarity on it. Suppose this error is 2 and this is minus 2, this is 3 and this is minus 4, this is plus 4, this is minus 3 like this. If I sum all these things, then error becomes 0, right? Error becomes 0 means that is the line what we have taken or the curve what we have taken is passing through all the points exactly, but it is not real, right? Because there are errors, positive errors as well as negative errors getting cancelled, so that it is not giving the exact line what we are looking for. So that is to avoid this, what we do is we go for the squares instead of this. Error can be positive or error can be negative. Therefore, what we do is we will go for error squares. Right? That's why we say error square. E1 square, E2 square, E3 square, E4 square, like this we can have total sum. Wherever the sum becomes minimal, that is the curve which is best fit for the data what we had. That is called as a regression equation. Okay. I hope that the concept is clear. This is one of the important concepts. Right? How the points drawn from the table that you showed, right? No, this is not. This is not. I have not taken this actually. This is just for discussion. This is something which I took just to show what happens if I take a straight line. What happens if I take a curve? Right? These are not dependent actually. This slide is different. This slide is different. This slide, how to draw the line? Just to understand it, I have drawn the line. But actually, what we are going to is we are going to find out the values of mx plus c. That will be written as beta naught plus beta 1x. So we want to find out the values of beta naught and beta 1, where most of the points are nearer to it. To have this, what we use, we'll take the help of this method of least squares. Right? So we are not going to draw the line, but now we are to understand the concept. We had the discussion where but we are not going to restrict the number of independent variables. The number of independent variables can be many, where you can't do this. So is there any ambiguity in the concept? This is one of the important concepts actually. Right? So what is correlation? What is regression? In regression, actually, what we are going to do this, what we are going to do. So what is the concept we use? Yeah. Why we square the errors is that to magnify the error value. That's not what I have explained now. If I want square, what happens? Just I took an example where the positive errors and negative errors all finally becomes zeros. That means there is no error in the approximation. That means all the points are lying on this line itself. But actually, if you see, it is not lying on the line. So to avoid this, what we are doing is we are taking the errors with the squares actually. Okay, right. So in regression, what we do is we'll try to fit a relation in the sense here we'll try to draw a curve or the line where most of the points are nearer to the straight line. For which what we do is we use the concept called as method of least squares. The MLSE, I think some of the textbooks they name it as method of least square errors. MLSE. Non-linear is nothing but if you generally if you see here these two representations. Here we will try to establish a linear relation, but actually it follows a non-linear relation. Right? We are trying to establish a linear relation, but actually the data perfectly follows a non-linear relation. Non-linear relation means where the linearity and non-linearity, right? That is what. But for simple understanding, if it is a straight line, linear relation. Otherwise, anything apart from a straight line comes under non-linear relation. Linear means, yeah, perfectly. Linear means y equal mx plus c, or c becomes 0, y equal mx. That is called as linear relation. But why I am asking, it need not be only mx plus c. It can be some more things added also, right? It need not be only mx, y equal mx. Here in this case, what we have seen is, suppose if you take this. So income and expenditure, but if you see income depends not only on expenditure. Expenditure not only depends on income. Right? Some simple example: your salary hike. Salary hike. Suppose if you take, you want to estimate, try to establish a relation. By using this, you want to estimate the salary hike. Right? But in general, salary hike depends on what? Not only one parameter, right? Maybe I assume one is your performance, your team's performance, right, and your organization performance, right? All this, so your hike depends on not only your performance, your team's performance. Performance is the revenues. Not only team's performance, it is organization's performance, right? That means your Y means for you this bonus or the salary hike depends on X1, X2, X3. Right? That means we want to establish a relation between Y with X1, X2, X3. Right? That means we have to extend this discussion further. it is not one or more. No, I'll explain linear and nonlinear. Just for a while, I will continue. Then I'll explain what is linear and nonlinear. That is one of the important concepts. So now we will have some mathematical. I think Andrew uses this term called as the cost function. It is called as. Andrew Nagy uses this cost function. So no lines, actually no need to draw for just to understand the concept. I am saying that many lines are there. So but now once we understand, we are not going to try with many lines. Just with the help of this concept, we will come out with only one straight line. Right? If you are looking for linear regression or linear expression which fits into data. Right? So in reality, when we try to do this, we are not going to try with all possibilities. Right? This is the beginning to understand the concept. So to find the best fit, what we are doing, we are using this concept called as method of least squares. The MLSE, method of least squares. MLSE is called it is not cost function. This function is called as cost function. Now we will see how mathematically we can have that. Now if you remember, so what we do is we use the concept called as okay. So we'll take a break for 1 or 2 minutes, then we'll continue this. This is one of the important concepts. I think you have to enjoy this concept. This is the one which gives the confidence related to analytics. Actually, this analytics starts with correlation and regression, followed by many kinds of topics like our time series analysis, as well as principal component analysis, etc., etc. So we'll break for 2 to 3 minutes, then we'll continue further. Thank you.